In this video, we are going to discuss how you can procedurally generate a 2D island map in your Unity game. We will start by creating a terrain shaped like an island. Next, we are going to add some details like hills and trees. Lastly, we are going to spawn a player on top of our newly created map. Hi, I'm Peter and welcome to Sunny Valley Studio. You will be able to download this project for free from my itch.io page. You can find the link in the description of this video. To procedurally generate a map or anything else, we usually use some noise generating function like Perlin or simplex noise. Next, we simply specify how different noise values should be mapped into different terrain types. But how can we make it look like an island surrounded by water? One way is to generate a circular mask based on the size of our map and next subtract from our noise values the circular mask, or to multiply both and use some threshold values to get the higher values of the noise as ground and other values as water. The mask divides the map into water and ground tiles. To make the output less rounded, I'm applying first noise data to modify the edges of our circular mask and then use another noise data to apply some details like water and terrain. This will make our island look more natural and also add some inland water onto our map. And this will be the base for all the other steps in our procedural generation system. Now, I want to swap the water tiles surrounding the island to be a different color. To do that, we are going to get all the tiles connected to one of the edges of our map using something like a flood fill algorithm. To place the correct tiles, I'm using rule tile implementation in Unity, so that it selects the correct sprite based on the neighbors of our tiles. The map generator script will have a list of generation steps as well as it will trigger the map rendering and the collider generator. The generation steps will modify the generation data, which stores different arrays and hash sets that store the data about the map that we should render. The map rendering script will store the references to the tile maps as well as to the tiles, so it is very easy to swap those tiles for different sprites. It will also use the generation data to render the correct tile at a specific position. To be able to generate the different steps using different noise data, I have created noise data SO scriptable object that contains scale, octaves, persistence, and all the other data that the noise generation needs to generate different noise values. This should make our system more reusable and easier to extend. To make our map look more interesting, I have decided to add hills to our map. Using the noise data alone would place the hills across the whole map. Now, this doesn't look very natural, does it? So I decided to use the circular mask trick again and reduce the radius of our mask. This way, the mountains will be created only in the center of our island. Since I didn't have all the tiles to handle different layouts of my hills, I decided to keep my hills rounded and to add level 2 hills on top of the existing hill. To make that work, I decided to reuse the same noise data, but to limit the amount of hills that are allowed for the level 2. This ensures that hills level 2 are inside the area of hills level 1. Before we go any further, this video was sponsored by CodeCrafters. It is a service where you can practice coding in C# or any other language by recreating bigger projects like Git or DNS server. You download a starter project as a GitHub repository, write the code according to the given instructions and upload it to GitHub like you would when working collaboratively with others on a project. Since procedural generation is a bit code heavy, CodeCrafters service can help you get up to speed with C# programming or programming in any other language. Okay, back to our procedural generation. What we want to do with those kind of systems is to create layers. So first is the base island generator, so creates an island outline. Next we place hills, and next we continue with different steps to improve our procedurally generated map. This way we can easily keep adding to our generation new steps. For example, we can add a sandy shoreline around the edges of our island. To do this, we just get a list of tiles that we want to check for neighbors to find the edge, and the list of valid tile tabs that can be neighbors. So in this direction of this neighbor, we are going to go to find the shoreline. In case of our shoreline, this will be the water tiles, and we are going to go into the direction of sand tiles, and this is how we are going to find the edge between the water and the sand. Since we are using rule tiles to generate those different sprites, there can be situations where the rule is meant to be near a grass tile, but is also near a water tile, creating us grass where we do not want it. To fix that, I have implemented my own rule tile that accepts compatible tiles, so if I provided C-tile intersection tile and regenerate my map, you can see that it treats water as sand tiles and doesn't create us the intersection between the sand and grass. Next step is to add some details like trees onto our map. I want to differ the sand area from the grassy area, so I want to place denser areas of trees inside the grass area and sparse population of palm trees around the edges of the island on the sand. To achieve that, I will use different noise data for the green trees and palm trees, and also differ the amount of trees that I place, so there will be more green trees than palm trees placed on our map. Unfortunately, we have a problem. The trees are placed on the edges of our hills because we have no idea where those edges are. In procedural generation systems, sometimes we need to stop and gather data about the map that we have so far. For example, an additional step of hill edge interior detection will allow us to detect the edges and the interior of each hill level, so this will cause our trees not to appear on the edge because we can exclude those positions, and in addition we can place some different kind of trees on top of the hills. This code acts similarly to our shore extension code. This time we are going to detect is edge to tiles, so basically we have a list of tiles that are non-edge tiles. So if our tile touches all the tiles of those types, those are non-edges and we can add those to the interior area of our hill. If any of the tiles that is touching our selected tile is not of this type, we can assume that this is the edge tile and we can add those to the hill level 1 edge tiles and hill level 2 edge tiles. This logic works because despite the fact that those tiles on the hill and on the ground looks the same, actually in the data the tile type is hill level 1 or hill level 2 for whole area of the hill, while ground for the ground tiles that are not on the hill. Procedural generation is different from random generation in that we should be able to easily recreate a map based on some seed value. To achieve that, I have in my map generation data a specific seed applied, and in the shared project there also will be this toggle randomize offset in the map generation data. And in my map generator script that directs the whole process, I have this code that checks if the bool flag is true. I'm just randomly selecting a new seed and then applying it as an offset to the noise data, so the data that I use to generate my noise values. This means that all the noise generation and random generation logic uses the seed defined in the map generation data, so we can repeat the generation of each noise generator based on this one value. Now, to make it work for the random tiles that I'm using to place, for example, the palm trees, I have also created a custom random weighted tile. To make it work, I have just copied the random tile code from Unity and added here a random value generator that I initialize using a custom seed, and in the map generator I have a list of random weighted tiles and use the same seed to initialize those random value generators on those random tiles. So this is how, when placing a palm tree using my code, I can ensure that this will always be the same sprite whenever I regenerate my map. To render those trees, I'm just using a separate tile map because this allows me to add to the tile map collider 2D and to generate basically colliders for each tree that I place. On the other hand, our hills are on the same tile map as our sea or our ground. So to add a collider to our hills, I'm just creating a collider hills tile map and I will place on it only the tiles representing the edges of our hills. The problem with this approach is that if I just draw an edge, the sprite here is different than if I draw the whole hill. The sprite here is much smaller and those edges are much smaller than the central edge here, because this would generate a bigger collider. So the problem is that here this sprite, if I generate for it a collider, the collider is much smaller than for this part here. we're going to generate this much bigger collider. So if we place bigger tiles, like this one, we're going to generate the collider for the whole tile, and it should be much smaller if this is an edge. So to ensure that I can paint only the edges on my collider hill tile map and that the collider is generated correctly, I had to create this hill collider helper that will map the sprite placed by our rule tile to a separate tile-based tile that represents only the sprite that is an edge. But one more thing that rule tile allows us to do is to use the same tile and just rotate it to make it fit our design, which makes the collider appear differently based on the rotation and the mirroring of our tile. So to take that into account, I need to read the matrix 4x4 from the base tile map for the tile position of the hill's edge and to apply it to the collider hill's tile map that I am setting so that the collider is correctly generated. Now, the same way that we have added the shoreline, we can add a shallow sea and deep sea to our map, and I can also add some grass to be spawned on top of our ground tiles, and basically this is reusing the same methods that we have discussed. Now, it would be good to be able to spawn our player or other objects on our map. To do that, I'm just using the map object placement data generation step that will detect the free or open positions on our map. Basically, it will just find all the positions that are non-hill edge and non-trees and will mark them as open for placement. I'm not including the sand areas, but basically that's how we can place objects on our map. And in my project, player placement generation step showcases how we can do that. In the script, I'm just creating a prefab placement random value using the same seed from my generation data and just selecting a random position and instantiating there a prefab. So the player generation step just randomly places our player on the map and we zoom onto the player so that we can walk around the map. I have also added a tree cutting logic because there is no telling if we are not spawned in between those trees and there is no way to get out, so we need to cut some of those to clear a path to walk around the map. To spawn bigger objects on our map, we can just analyze the neighbor tiles around our selected position to decide if they are free of the obstacles, so if we can place there a larger object. One remaining issue is that sometimes we are going to be spawned on top of the hill, but currently there is no way to enter or exit any of those hills, and since there are colliders, we are not going to be able to get down. The solution is obviously to add another step for our generation that will just select a random position on each hill and uses a star pathfinding algorithm to create a path from the hill to one of the edges of our map, clearing all the trees and all the hills on its path, and we are going to also place a staircase on the first hill edge that we detect. Now the problem is that we may also remove some of the hill edges when we do that, and we can end up with trees being spawned on top of the edge again, as well as if I select the collider, the hill's collider, and I'm going to enable the wireframe mode, we sometimes can see that the collider has those holes in it because we have just removed some edges from our hills during the staircase generation. The solution to this is to add two more steps. The first step will be again the hill edge interior detection, and we are going to just detect again the edges and the interior of the hills, and we are going to have a step that will remove the tree and grass that are already placed on the new edges. After running this new generation step, you can see that the tree was removed from the edge of the hill, and now the hill collider that was previously deleted is now complete with the hole for the stairs so that we can go up and down the stairs and climb up the hills and go down and reach the other areas of our terrain. Unfortunately, there can't be the hills that cannot be reached, but this should mostly cover all the hills that we have generated on our map. And basically this is it. Now I haven't placed anything on the hill level 2, but basically we have now the staircase that we can reach, and we can climb down the stairs, we can cut the trees that are in our path, and now we can go and explore our procedurally generated island. Thanks a lot for watching, and remember that you can support my work by becoming my Patreon. The link will be in the description.